right, second graders, we have our last section of this part of our unit, melting and freezing. And we're gonna write a little report. Don't get overwhelmed with the word report. It's just a couple of sentences. We're gonna help a company solve a problem based on everything you guys have learned.
Ooh.
Yeah. So I think that you have the problem over there, and Miss Marquardt's gonna get that while I kind of talk to you about this a little bit. So we're gonna help solve an ice pop company's problem. We're gonna read you the problem right now, and then we're gonna go through, write a little report and make sure that we answer all of these questions in the report. So we'll read the problem first. What's our problem?
All right, so here's the problem. We have a fruit juice pop company, like an ice pop company, and they were getting a batch of ice pops at their factory, ready to send out to different stores, but something kind of strange happened.
What happened?
Well, the ice pops were in plastic wrappers, but they don't seem to look like ice pops anymore.
What do they look like?
Well, instead of the pops being nice and solid and cold and frosty, now the plastic wrappers are just filled with liquid that's warm and runny.
Huh.
It kind of reminds me of like an otter pop.
It's what it reminds me of too.
So the stores were just getting them all like liquidy and runny, and they're supposed to be nice and cold and
solid,
frozen,
right?
Ready to eat.
Okay, so
we've got a problem.
It's a good thing we've done a lot of investigations this week, learning about reversible and irreversible changes and heating and cooling things to create those changes. All right, so we have this ice pop company who has all of these liquid ice pops that are no longer frozen, no longer solid, no longer in a form of a popsicle. We need to give advice to this company about what they can do to get those ice pops back into being ice pops and not being liquid anymore.
Yeah.
Okay?
Help them solve that problem.
Can you walk us through what our checklist is here first?
You bet. All right, so we're going to be writing a paragraph, but we're going to break it down into a few different sections. So we have our introduction, that's going to be the beginning. And in the introduction, we need to explain what happened to the shipment of ice pops. And we also need to know what caused that change.
Okay.
All right?
Okay.
Now, when we get down to the explanation, that's going to be the middle of our paragraph. We're going to be describing whether or not the change is reversible or irreversible. So that's just like the orange juice and the egg.
Okay.
Whether or not it can go back to its original form or not. And we're going to be using evidence from the investigations that we've done already in class to explain our answer. And then finally, at the conclusion, the end of our paragraph, we are going to decide if the change can be reversed. Then we're going to tell the ice pop company how to reverse the change. And if it can't be reversed, then we're going to try and give the ice pop company some advice so they don't ever get into this strange situation again.
All right, so we have already done some work for the kids to help them create their paragraph. We have what we call sentence starters here for you, where you're going to copy what we've already written down, but where this blank line is, you need to fill in the blanks with information that we are talking about, information that you know from our past experiments this last couple of weeks, and knowledge that you guys have on this topic. So, to answer our introduction here, what happened to the shipment of ice pops and what caused the change, we have our first two sentences. This is our introduction. So let's see what it says. The shipment of ice pops, it's asking us what happened to them. So we have to fill in the change, or in this space right here. Yep. What happened to the ice pops? The shipment of ice pops exploded? Did they disappear? Did they melt?
I think they came to the stores liquidy and warm and runny.
So they came to the stores liquidy, melted, runny, not frozen anymore. Okay, so that's something we can put right there. And the second part says what caused the change. So our starter for that sentence says the cause was, so we have these pops that are melted, right? What was the cause of them melting? What do you think?
Well, we already know that if something is supposed to be frozen, it means that something cool should have been given cold air, put in something cold. So we already know that if they came melted, some type of heat must have been added.
Okay.
And again, that doesn't mean they put a fire underneath it.
That could have just been it was taken out of the freezer and left at room temperature for too long.
Exactly.
Okay, so what the cause was basically that it was heated,
Yeah,
right?
heat was added.
Heat was added. All right. Now, going into the second section of this, the explanation, we need to answer the questions, was it reversible or irreversible? So when we take these ice pops and they get melted, is that something that we can reverse? Can we refreeze them and turn them back into ice pops, or are they always going to be melted forever and ever and it's reversible? Okay. And then use evidence from our past experiments to explain. So here we go. The change is, what are you going to put in this blank where it says the change is? You're going to write either reversible or irreversible. So what do we think?
Well, these ice pops remind me of the frozen glass of orange juice.
Yeah.
So I'm going to say that the change is reversible.
Reversible.
And then this next line where it says because, and we need to use evidence, I think that glass of orange juice is really great evidence. So the change is reversible because juice can be frozen and unfrozen.
Yes. All right. It can go back and forth between being liquid and solid. Excellent. Yeah. And now finally our conclusion, we had to decide, well, we already decided that this is a reversible change, right? It can go back and forth. So the top one says, if the change can be reversed, tell the ice pop company how to reverse the change. We're going to stick with the top one because we know it's reversible. We already answered that. We don't need that bottom one. It can be reversed. So now we just need to give advice to the ice pop company about what they should do. Okay, you have all of these melted ice pops. What could you do to return it back to being frozen? The company should blank. What should we tell that company? What should they do?
I'm kind of excited to hear their ideas for this one.
Yeah.
And hopefully they don't say, like, heat them up.
We're not going to tell you. You should know the answer to that by now. But pause the video at any point so that you can copy these. Rewind if you need to get the answer to all of those, but you're coming up with the answer for the bottom one. Now, at the very, very bottom here, your challenge is to add illustrations or diagrams to a report. We've already added these cool 3D looking arrows here. Well, 2D, but they look cool. I like them.
Thanks.
And the reason we did those is because maybe you want to do a step-by-step process. So what did they look like when they were first made? Maybe they were nice, frozen, cold pops. And then when they arrived, they were melted and they were watery and liquidy. What did they look like? You could do that here. And then maybe after the change that you guys suggested to them, the advice you gave, what would they look like again at the end? If you have a different way to illustrate that, you don't have to copy what we gave you as an example. You can do whatever you want and be creative with that, but do include some kind of illustration to go along with your report. Yeah. Yeah. Is that it?
I love it. I think that is everything. This was a really, really fun unit that we just did in science.
I had a lot of fun. Hope you guys did too.